Nikki, on the number of participants, do we wait for a couple of minutes?
Yeah, I think we should. The number of participants is joining in. We have
It's
joining.
It's about 15 now, 15. It's 21 now. We have certain groups from a few colleges who are registering. So we have 32, 35. It's very nice to see the scoring sheet. It is 36 now. Tim, do we start at 50? We stand at 40 now.
No, we can wait a little longer. I think it's going up faster than Twitter's stock is going. So
yeah, we have about 43 participants. 44. I'll start at 50. I'll take a few minutes and then we will request Mr. Balaguru sir. So that gives us some time for more students. And
yeah,
more
get a slow start.
Yeah. Greetings to all participants. A very, very good morning to delegates who are joining from India. A very good evening to delegates who are joining from the US. And good afternoon to delegates from Taiwan. We have a few delegates who are joining from Uganda. So that must be very early morning for them. So we have a reasonable success in making this series to reach out to different geographies. Our sincere thanks to Elcon-Precision and the leadership, Mr. Tim Dyer, Mr. Ed Tomasek, and Madam Nikki. Greetings to all participants again. Explore the Space in association with Elcon-Precision is very pleased to present the 6th and final edition of this webinar series, Future of Space Technology and Exploration. What started in June, to be very precise, 25th June 2021, about 18 months back. We have had 5 editions and today happens to be the 6th edition. So Nikki, can I request your help in running through my very short presentation? We have about 68 participants. I would request all participants to mute. Thank you, Nikki. So, that's the international webinar series that we started on Future of Space Technology and Exploration. For today's webinar, we have an excellent galaxy of speakers, starting with Mr. Balaguru sir, who is going to do the inaugural. And then we have Mr. Kwang Han Ki, the President of Grand Systems, to be joined by Mr. Ed Tomasek, Director of Business Development, Mr. Tim Dyer, President of MathC Innovations. Welcome, distinguished speakers. Explore the Space is an NGO promoting space education across geographies in association with Elcon-Precision, a metal finishing company and a direct supplier to NASA, bring this series. As we all know, gentlemen, the objective of this series is to encourage youth to pursue STEM education, in particular space sciences, to facilitate industry institution linkages, and to emphasize on global space cooperation. And I'm very glad to say that on all these 3 counts, we have achieved reasonable success in the past 18 months. Next, we have, there you have Mr. Tim Dyer, who at that time was the Managing Director of Elcon-Precision LLC, that was June 2021. Dyer, a core enthusiast of space, is the founder of MathC Innovations. We will hear about this more. This was in June 2021, the first edition. And then the second edition, we had Mr. Jaideep Mukherjee, a scientist from NASA, who spoke on NASA's Artemis mission. And then For the third edition, we had microsatellites, which featured Nikki, Rebecca, and Tim Dyer. That was Team Elcon, who made a fantastic presentation on microsatellites. That was in November 2021. And then we moved to the fourth edition, where we had an excellent speaker in Dr. Ram Prasad Gandhiraman, founder and CEO of Space Foundry, who spoke on human exploration of outer space, past, present, and future. This was in February 2022. And then we moved to the fifth edition, where we had a great presentation by Mr. Scott McCormack from the University of California, Davis, who spoke on materials for planetary exploration. So that was in June 2022. And then today we move to the sixth edition, where we have a galaxy of speakers today. On the speakers for the inaugural, we had Mr. Nagendra Prasad, the Consul General of India in San Francisco, Madam Grace Akello, Ambassador of Uganda to India, Mr. Nitirush Pone Prasarat from Thailand, Mr. Joseph Abraham from Israel, Madam Mamta Rani from AICTE. That's the key association that regulates technical education in India. And today we have Mr. Balagurunathan. So these set of eminent ladies and gentlemen have been very kind enough to inaugurate our webinar series. On the careers in space industry, we go with the mission to spread the message that technology is not only the opportunity for space exploration today requires, and it provides opportunities for space medicine, space food, space law, and a host of other careers. So this is the message that we are trying to take to the youth across geographies. Next, please. We are in the mission of building a future workforce for the space exploration industry. This is exactly what we are trying to do through our various programs. Next, please. In partnership with Space Tech Expo, we participate in exhibitions in California, Long Beach in May, and in Bremen, Germany in November. We are shortly launching an online certificate course on basics of global space technology and industry. Next, please. This is supported by Elcon Precision. Thanks to Elcon, we hope to launch this in Christmas, our latest by January, should not be later than that. And our sincere thanks to Elcon for making this happen. We look forward for the support from other companies, research organizations, and industries across the world. Next, please, as we come up with this very interesting course on online certificate course on space technology and industry. Next, please. An important point that we would like to drive home is space technology or space exploration is not a standalone. It is a confluence or convergence of so many concepts and technologies that makes space exploration what it is today. It involves advanced materials, it involves artificial intelligence, it involves data processing or data analytics of the very highest order. So again, to repeat, the point that we are trying to drive home is the youth of today may or may not be directly interested or involved in space exploration, but then if they are going to pursue a career in technology or anywhere close to any technology, then that technology is certainly related to space exploration. So we welcome more and more youngsters across geography to pursue space exploration. Next, please. We welcome students to join our international student membership. We are sure that we provide value as we coach and as we mentor the youngsters. These are points in edition 1, 2, 3, next please, 4 and 5 that have been elaborated by the different speakers. The last one, very interestingly, as told by Scott, was how fast is fast, how hot is hot, and how strong is strong. That was what Scott made out in his brilliant presentation on materials for planetary exploration. Today, we have Mr. Kuang, who's going to speak on, in his keynote speech, on space education in today's scenario. Next, please. That's about my presentation. So, ladies and gentlemen, as I just mentioned, we have an excellent person in Mr. Balagurunathan, who we are going to request to make his inaugural remarks. A few words about Mr. Balagurunathan. Mr. Balagurunathan, as I mentioned, is a very, very passionate teacher. He's a very passionate teacher. In fact, I've known him for 5-6 years now. I wish every science teacher emulates aspects of Mr. Balagurunathan. He travels, I mean, if I can use the word crazy, he travels crazy. He travels across the length and breadth of the country. He was at some other place yesterday on a national science mission, conducting quiz programs, doing experiments. We are on Wednesday morning. This is Wednesday morning. On Sunday morning, I had the opportunity of having Mr. Balaguru at the office of Explore the Space in Chennai, India. We were explaining to him the small experiments that we do on centripetal and centrifugal forces. We have a small box like this, and we put small balls and we rotate that, and we say that as long as the centripetal and centrifugal forces are in balance, the small balls inside will not come out. And then Mr. Balaguru came with an excellent idea. He said, you pour water into that, and even the water will not come out as long as the centripetal and centrifugal forces are balanced. So, spending time with Mr. Balaguru is a great opportunity for us. And we welcome Mr. Balagurunathan, who is a retired principal in a famous school in Neyveli. He has written very many books. He has written books on chemistry. He has written books on various other topics. He works closely with the government of Tamil Nadu in promoting STEM education. He is an awardee of Times of India and also NCERT awardee. With these words, I welcome Mr. Balaguru for your inaugural address. Mr. Balaguru, sir, please.
Thank you for the opportunity, sir. Ladies and gentlemen, respected Venkatagiri, sir, our long road companion, Mr. Tim Dyer, sir, our platform to popularize space career, Helicon Precision LLC, and our beloved director, Mr. E.D. Tomasek, today's honorable chief guest, Mr. Kong Han Ki, President, Grand System Taiwan, and distinguished academic professors, lecturers from various institutions, and my dear students and participants. First of all, I welcome you all. With the Helicon, we arranged 6 international webinars for space aspirants and college students from various science and engineering colleges. In these services, our experts covered various fields. On June 2021, advanced material for launch vehicle. September 2021, NASA Artemis mission. November 21, microsatellite manufacturing and operating technologies and challenges. February 22, human exploration of outer space, past, present, and future. June 22, material for planetary explorations. Through this, space aspirant can gain many more inputs. By today, we are going to observe a lecture from Taiwan by Mr. Kong Han Ki, President, Grand System Taiwan. Today, space industry enabling global cooperations in space education. Already, our Tim Dyer gave various lectures on material fabrications and new material for modern launch vehicle. Today, he is going to share his enthusiasm as a journey of space enthusiast. We wholeheartedly extend our thanks and gratitude for your extended and sustainable support for popularizing these lectures, sir. The world has shrunk due to invention of science. We are now the citizens of one world. Through this platform, we are igniting the young minds and killing their aspiration for space career opportunity. To add one more feather to our crown, today we are going to observe precision components for satellite, an eye-opening lecture by Mr. E.D. Tomasek, Director, Business Development, Elcon Precision LLC. For the college students, our participants, this learning also help pursuing serious scientific research, which would pave the way to the advancing front of knowledge. For those who are infected with a thirst for research and discovery, the scopes and opportunities are numerous. The global space sector has made tremendous growth over the decade. The country's participation in space program have been highly remarkable. This advancement was rightly pointed out by Mr. Mamta Rani Agarwal, AICT Advisor 1, Ministry of Education and Government of India, New Delhi. In the space science, our next level of quantum aim is to invest in space to serve Earth and beyond. Based on this, in future, we are ready to do deep space research on the space operations. Such efforts are graced by our various eminent personalities, Dr. T.V. Nagendra Prasad, Consul General of India, San Francisco, Mr. Joseph Abraham, Consul General of Israel in Bangalore, Her Excellency Ms. Grace Akillo, High Commissioner of Republic of Uganda to New Delhi, His Excellency Mr. Nitro G, Consul General, Royal Toil Consulate General, India, Chennai. The above eminent personalities grace our various webinar series to popularize space science among young minds. The aerospace industry is a multidisciplinary sector and also require multidisciplinary approach to formulate new material and machines. For this approach, if you ask who is the fittest person, one who pursue STEM education and STEM scientists are the fittest. So my dear students who are listening this 6th edition should pursue STEM education and take a lot of internship from VSRP and IISR, if possible from IIT and IISc. Aerospace is a booming industry around the world. The current estimate predict that the revenue generated by the global space industry could increase over $1 trillion by 2040. So space aspirants can get the suitable career positions in aerospace industry. We are ready to guide you on behalf of Explore the Space, and I thank you for the opportunity. Thank you.
Thank you very much, Mr. Balaguru, sir. That's some very interesting message, both for the student community as well as for the business. As rightly pointed out, business opportunities are booming like anything. Ladies and gentlemen, our sincere thanks to Mr. Balaguru, sir, for his inaugural address for the 6th and final edition of this webinar series. Now we take pleasure in introducing Mr. Kwang Han Ki, President, Grand Systems. A few words about Mr. Kwang Han Ki. Mr. Kwang Han Ki holds an MS in Aeronautics and Astronautics from Stanford University, California, USA. He has experience in industry, government, research, academia, in global industry associations, particularly in the semiconductor industry. He has over 29 years of experience encompassing a mix of industry and teaching. He's also the founder and chairman of Grand Systems, a company that engages in system integration, design, think tanks, and manufacturing in new space and medical equipment. His recent contribution includes the subject matter speaker and mentor on the subject of Asia-Pacific Space Development in the Asia-Pacific Space Generation Workshop, organized by the Space Generation Advisory Council, United Nations. Over to you, Mr. Kwang. We welcome you for your keynote address.
Thank you, TV, and thank you, everybody. And it's an honor to be here to share with you the topic on the space education. And I will share my screen now. Is the screen okay?
Yeah.
Okay, the topic of my talk today is from today's space industry that will enable the global cooperation in space education. And this is a result of my past 14 years of work since I founded my company and returning from a lot of industry work in the semiconductor industry. And then after I founded my company, I was able to come back to my study when I was at school, to my initial passion after learning many years of learning at school. And I found out during my career that after I have started many of the engineering work and the government, industry, and the research institute and academia, and I ended up in finding my own role in my own company. Then, as many of you are learning right now, and I found myself at that point to restart my learning process after many years working. And I found out that I was able to go into an area which I had a lot of passion about when I was at the university and the graduate school. So I returned after many years of working into the space industry, and this is a result of the presentation today. So I will cover a little bit about the current space industry development and current education needs, and the technology development, and then the global cooperation in space. So first of all, we would like to understand what is the current global space industry development is. And from there, we can figure out how we can possibly design the space education need from top down and from bottom up. And then right now we see that we have companies working on large satellites and the traditional satellite industry, and also new space, what's so-called new space companies, and working on smaller satellites and new technologies. We have the operators working on operator of satellites. We have the space station. We have rocket companies. We also have innovative Earth observation satellite companies. We have weather satellite companies, and we have innovative air launch companies and many other companies that are in the areas of operation in the current space industry development. And these are, of course, being driven by the large companies that have driven down the cost of the launches in order for new participants to be able to have enter into the space industry, and big contributions such as SpaceX, and of course companies like Virgin Orbits and other companies are helping the international development and democratization of the space. And therefore, with these developments, we are able to have many more ideas and be able to let the space education being a possibility. And that industry currently are not only participated by the space giants such as SpaceX and Virgin and other companies and Amazon and other companies, but however, many other companies that we don't think about, such as Coca-Cola, Procter & Gamble, IKEA, they are also working greatly in space and make the universe is our laboratory. And of course, my company, Grand Systems, is also thinking about entering the same research and the opportunities that we would like you to understand that what the industry is going into. And of course, from those developments, we are thinking about the students and think about the space education needs. How would the students needs to develop in order for them to be future talents for the space industry and beyond? And of course, right now in the industry, because of all the capabilities that we are talking about, we are able to have the new concept of the universe is our classroom. So some of the industry and all the space agencies would have some information and teaching kits for elementary school, junior high, high school, all the way to university and graduate school. For example, my company has participated and co-organized in several events, such as on the International Space Station, and we help co-organize the first, second, and third in ISS Kibo Robotic Programming Challenge, which is organized by JAXA from Japan and NASA from the US. And then we organize another ISS event, such as the AI Space Challenge, and co-organized by 4 private companies, which Grand System is a part of. And of course, currently, many ISS education kits and other teaching kits are also available on the market to address the needs from all the K-12 and also university education needs. From that, and there are also United Nations organizations such as Space Generation Advisory Council, and they organize many activities around the world. And I have the honor to participate in the Asia Pacific Space Generation Workshop as the subject matter experts and the mentoring activities, especially on the specificities of Asia Pacific space development topic, which I addressed 2 years ago. So with that development, we can think about on the technology side, the small satellite development and let me see, small satellite development status. And I will first address on the from our point of view on the system integration side. What is required? And of course, we can see there has been some development on the NASA side with many small satellite developments, and of course, large scientific satellites such as the James Webb Telescope. And of course, the newest development is the NASA Artemis rocket, which was just launched on November 16th, which I was there to see launch in Florida, right in front of my eyes, and it was quite eye-opening experience. And of course, with the development of SpaceX, it changed the industry and many technologies around the world. And on the left, you can see the Falcon 9 rocket that is launching. And this one carry one of my work, which is a CubeSat, this Saturday. And we were able to have a small companies like us being able to have a small satellite being launched by a big rocket from SpaceX. And of course, and you can see on the right, that's the on the Falcon 9 with the transporters, SpaceX rideshare program transporter mission. On the top, you can see many of the slots that can put the smaller satellites. And of course, at the bottom, you can see the Starlink satellites at the bottom. And these are the newest developments around the industries that help the small satellites to go into space very economically. So a very brief summary of what we do in Grand Systems. And we are a small company, but we have a heritage of 14 years. And in the business of new space, medical equipment, and semiconductors, working on system integration, angel investment and incubation, and think tank. So we were the first in-space, new space company in Taiwan 14 years ago. And Taiwan is a country with later development than countries such as US, Europe, region such as Europe or Japan or India. And we are latecomer in this arena. So it took us quite a bit of struggle and trial and error to be in this situation. So we started looking around to see what we need to do, and we started developing our own products. And we started from Taiwan, and because the space industry is global, because the time that you launch your satellites, it goes around the world. So it needs to be then from Taiwan to everywhere. So that's we need to work on that every day. So as you learn at the university or high school, and you for the space studies, you would need to think about not only the technologies, but also think about you will need to understand what the application is and how you develop your skill set to become more globally aware of the development. So in the process, we have developed a very tiny small satellite, 2-liter satellite. It's only the size of the bottle, 2-liter bottle drinks. And we developed the CubeSat bus, hardware, and missions. And this week, it was just sent to the International Space Station Saturday and Sunday. So this photo is very recent, just about 1 day old. So you can see here, our satellite was seated inside the Crew Dragon spacecraft on the CRS-26 mission, which is next to the Crew 5 Dragon, which is carrying the astronauts into the International Space Station. And of course, we need to deploy the satellite, the small satellite. So we have the deployers to deploy the satellites. And of course, once we make one, we make several more for universities such as you. And so you can have more economical and quality parts in order to quickly develop your space missions. If you are, for example, in the university or graduate school that you need to graduate soon. And we tried, so you can use the already made products from the industry to catch up the flight and to catch up the launches, and of course to catch up your graduation date. So after we develop our products, we have been the first company in Taiwan to be listed through third-party referral on the NASA website. And that was fortunate, and that we are recognized to be good products in the industry. And of course, later on, we have developed these products that are mostly for the academia usage. And so we mass produce our products for the universities to be able to quickly develop space missions and learn in the universities in order to be ready for the job market. And of course, with the CubeSats, some of the CubeSats will start to have propulsion, so we can integrate with the propulsion with the CubeSat on the design vehicles. And then besides the CubeSats, we can do other subsystems that are carried to the space for other people's satellites, and to help globally and collaborate globally in other space missions. And these spacecrafts are carried by different spacecraft to space, or by different rockets to space. And for the satellites or space missions that goes a little further away from the Earth, not only in the low Earth orbit or medium Earth orbit or geo orbit, some of the satellites or space missions will go to other locations away from the Earth, such as lunar orbit. And these, the photos that you are seeing here is a result of the space exploration and the engineering required for such activities. For example, if you think about like the recent Artemis program, which is a follow-up of the Apollo lunar landing program 50 years ago. And if we are going back to the moon and have people landing on the moon, we need to understand the environment that we will be on the moon. So on the moon, 50 years ago, we human beings have brought back 300 some kilograms of moon dust. And moon dust is, as you can see in the photograph here, they are very fine grain, and they go into many things, and sometimes it causes difficulties in engineering and making human being living on the moon very difficult. So we need to study the lunar regulars, and since we have only brought back 300 some kilograms, it's important to have the researchers using the lunar regulars simulant in order to make the engineering happen so that we can go back to the moon again. So other than the small satellite missions, currently a very important infrastructure in space is the International Space Station. It is the largest satellite around the Earth. It's about the size of the football field, about right now is the time of the World Cup. So the size of this International Space Station is the size of your football stadium. However, the part that astronauts would live is only a 6-bedroom apartment. And it can carry sometimes between 3 to 12 astronauts from different countries. And the International Space Station is powered by the large solar panels, and and we are fortunate to become the International Space Station gateway company in Taiwan, and especially serving the experiments for food, biotech, pharma material, and commercialization. And this is a very good space science and commercial space practice platform. You can do many experiments inside. For example, biology, materials, human health, food, environment, next generation technologies, new space commercialization, etc., to develop new space economy. For example, the most successful experiment in space is called the space whiskey experiment, and you can develop the taste of the whiskey in space to develop new recipes. And of course, there are many astrobiology research, such as cell research, new drug development, and test efficacy in space. You can grow protein crystallization in space. You can research tumor, and of course, space biochip research, etc. Of course, if you need to travel in space and do space tourism, you need to have food. And an important part of the food is the vegetables. And these vegetables are grown by the astronauts, and half of them are used for experiments, and the other half is for the astronauts to eat. And of course, in Grand Systems, we are developing a small space factories in a drawer like this in the International Space Station. And of course, we welcome you to join us for other zero-G microgravity research on Earth, and as it is in space, experiment space to the International Space Station. And all these infrastructures are available and for people to use. And so if you have good research projects, please feel free to work with us, and together we can make it happen. So global collaboration in space is very important, because for example, a satellite goes into space, it doesn't only stay on top of you, it goes around the world. And if you spend so much money, you only use the time above you, it's a waste of, it's a pretty waste of your budgets and money. So it's good to share with others as you go. And it's also good to learn other people's culture and have collaboration, so that you can reduce the burden, economic burden, to make space happen. And the future possibilities, and we started with the small satellites, we started with education, we started with the International Space Station and future possibilities. And the future is bright, and the human beings are currently working on space flight possibilities. And we have some vehicles to go to space to not only carry cargoes, but also human being to space, even though it's a very initial stage. And we are currently developing commercial space and then possibly going into space travel. So in your generation, this is what's coming and happening right now. So we hope you are able to learn a lot at school and in the future be able to solve issues. There are many things around the world that needs your talent to develop the tools to solve current and future problems sustainably. And there are many United Nations Sustainable Development Goals that you can develop and help others in the humanity. And the work continues, and I hope you join the bandwagon. Thank you very much.
Thank you, Kwang. That was an excellent presentation. You took us through the entire breadth of the great work that you're doing. A sincere thanks to you. Ladies and gentlemen, let's give a big hand to Mr. Kwang for his presentation. Thank you again, Kwang. Now, we move to the next presentation on precision components for satellites to be made by Mr. Ed Tomasek. The very interesting thing about Mr. Ed Tomasek, who is a leader in space industry today, is Ed had a BS in biology. So from a BS in biology, that's a great travel today to be a space enthusiast and to be a space leader. Ed Tomasek has a BS in biology and an MBA, both from the University of California, Irvine. Now he's the Director of Sales and Business Development, Elcon-Precision. He is responsible for bringing in new business to Elcon for both the etching and assembly sides of the company. Before coming to Elcon, Ed Tomasek spent a combined 20 years in ceramics industry. Now I have pleasure in requesting Mr. Ed Tomasek for his address on precision components for satellites. Over to you, Ed.
Thank you, DV. Let me get my presentation up here. So this will be a fairly short presentation on some of the components that Elcon has in space. And one of the things I want to impress to most of the students out there, all the students out there interested in space exploration and doing things in space, is that we're a small company. Our major business is not in space, but we still get to do a lot of space projects. And just want to encourage people that you don't have to work for SpaceX or Blue Origin or any of these huge companies. You know, you can work for a small company like ours, or Grand Systems like Guang discussed earlier. And there's just a lot of exciting other projects out there that even little companies like us can do. So I'm just going to go through a few of the projects that we have in space and tell you a little bit about what we do. So we're a company founded in 1967. We have around 55 employees, and our plant size is about 34,000 square feet. We're privately owned. Our ownership group has several other companies, some of which also do space business. We have all the certifications you would need to do space business, AS 9100, ISO, RoHS, ITAR if you're doing defense work. And we've got a lot of talented people, a lot of engineers, but we're just a manufacturer. So it's a team of material scientists and fabrication experts. We're in the Silicon Valley, which is in the Bay Area. And we just love to pursue creative solutions to provide precision components and assemblies for all kinds of mission critical applications. So this includes space, but it's also medical, semiconductor, alternative energy, things like fuel cells, And it's just a great place to work. So I'll go through here some of the products that we have in space or had in space. So right now there's this device that you see on the slide here. It's on the Solar Explorer satellite, and it's an imaging gradient for looking at solar flares and to characterize other aspects of the sun. And it's made out of tungsten, and it's etched. You'll see later on some of our etching capabilities. And it's got different grading widths on a fairly thin piece of metal. So what you see on the right is the drawing of what we etch, but in the middle there, we stack these together, and then they get diffusion bonded together to make about a 1-inch stack of materials. So you need something like that in order to do this work. So it's a very creative solution to a problem of trying to look at the sun through tiny, narrow gratings. We also work with SpaceX. We're on the Starlink satellites. So when Starlink is, for those of you who don't know, Starlink is a communication satellite for cell phones. So there are, I think there's probably 5,000 or 10,000 in space right now, constellations, and they talk to both each other in space and to Earth, obviously, if you're going to have cell phone service. And while they're in space, they speak to each other with lasers, and our component is a critical part of that communication between the satellites while they're up in space. I wish I could show you a part, but SpaceX wouldn't be too happy with me. But suffices to say that we're on thousands of satellites up there. We also make plates for fuel cells. These are fuel cells are a way of creating energy from hydrogen and oxygen, and the plates are both supportive, and they also they help route the gases that are used to make the electricity. And these are going to be important for anyone that wants to inhabit any other planet than our own. So you've got to create oxygen. None of the planets that we know of have sufficient oxygen, and you have to be able to create power, electricity. So if you've got water, which the moon has in the form of ice at the moon's south pole, you can apply current to that water, turn it into oxygen and hydrogen, and then in turn you can also generate power by using the hydrogen and running it through a fuel cell. So in one direction, you're creating hydrogen and oxygen, and in the other direction, using the hydrogen and oxygen to create electricity. So we make the etched bipolar plates, and these plates, they route the gases during the process of creating either the gases or creating the electricity. We were a participant in the DART mission that just smashed into a moonlet of the Dimorphos moon mission. So this was a mission to smash a satellite very fast. It was going 6 kilometers per second when it hit, to see if it could alter the course of that moonlet around. It's a pair of asteroids. One's very small, one is fairly large. The small one revolves around the large one, and we smashed, or NASA smashed a satellite into it very fast, and was able actually to alter the orbit just enough that if it did pose a danger to the Earth, we could alter its orbit and its trajectory towards Earth, and potentially save the Earth instead of us going the way of the dinosaurs when that large asteroid hit Earth millions, billions of years ago. So this next slide will show you our participation. So we made these two parts that are in red here, this electron gun and this neutralizing gun. So this electron gun takes xenon gas and ionizes it. And in the process, those ions are accelerated through these green grates here. And as they're accelerating through, it creates momentum and actually pushes the satellite forward. This neutralizing gun neutralizes the electrons after they come out so that you don't get kind of like a reverse thrust out of it. So this is a picture of the actual engine. This is this part right here in the middle. That's represented by the green here. So you'll see in like in sci-fi movies, an engine with a blue glow, and that would be this ion engine. So we were very proud to have a couple of components on there. Too bad that got destroyed, but it was an integral part of the mission. We also make etched electron optics. This works similar to the way that they're used on an ion engine. You're accelerating electrons through a grid. But in this case, they're used for communication, radio frequency communication. So you'll find them on communication devices on satellites. Same general electronics principle, but on a much smaller, a much smaller scale. So I'll tell you a little bit about Elcon Precision. We've got two divisions: our metal products division, which is mostly photochemical etching, and our ceramics product division, which is mostly metal to ceramic assemblies. So a little bit about photo etching. We take very thin sheets of metal and we put patterns on it using photolithography, which is a way of creating patterns that you can print with a laser printer. The process is burr-free, stress-free, and we can create both 2D and 3D components. You'll also hear names like chemical milling, photo etching, or photochemical machining to describe the same process. We do a large range of materials, refractory metals, which are metals that can withstand a lot of heat. So that's important for space. Right now we've got tungsten and molybdenum up in space. Also titanium in some satellites. We also work with pure metals, copper, nickel, palladium, and alloys, you know, the usual stainless steels, brass, and other metals. And we also do specialty metals commonly used for heat sinks. So this is just a real simplified graphic of what photochemical etching is. So we select the material, we laminate the metal sheet with a resist coating on both sides. And then using a laser printer, we digitally image a pattern on both sides, identical pattern front and back. And then we put it through an etching machine, which is just a sprayer. The part goes on a conveyor. It's got sprayers on the bottom, sprayers on the top. And as those chemicals spray, they remove the metal material that's not covered by the remaining photoresist. So you can imagine using a laser printer or a laser light, you can print very small, intricate patterns on a piece of metal. After it goes through the etcher, comes out, we take the resist off, and the part pops out of the sheet. So what you see there as an end product, that's a little antenna that goes for RF communications. But we can make small parts, large parts. Show you some examples here. This is a medical part over here on the left. It's used to detect brain waves. This part here to its right, that's a grid used for communication. This is a bipolar plate used for fuel cells and electrolyzers. This is a medical device that you stack these up on them together, and it's used for bone replacement. So spinal surgery, knee surgery. It replaces when you take the bone out or the joint out. This material replaces it, and being titanium, bone loves excuse me, bone loves to grow into it. And it's like having a brand new piece of bone, a brand new joint. And this part on the left is just another grid. So this is formed flat, and then we shape it into this hemispherical shape. This page shows a lot of the mostly small parts that we make. None of these parts is much bigger than a thumbnail, maybe 2 thumbnails. You can see some 3D parts, as well as just a lot of flat parts and partially etched parts to create steps and cut lines. So the other part of Elcon is our ceramic metallization and braze assemblies business. We take the process is we take a ceramic part, we apply a thick film refractory metal, which is molymanganese, molybdenum, and a little bit of manganese. We bake that into the ceramic, and now you have a surface that's stuck very tightly to that ceramic. And now you've got a base for doing brazing, which is a way of attaching metal to ceramic. We use an alloy. We put the alloy between the metal and the ceramic. We put a little pressure on it, and then we cook it at anywhere between 400 and roughly 1,000 degrees C. So this creates an insulated, electrically insulated, and hermetic seal at the ceramic metal interface. We do a lot of different ceramics: alumina, sapphire, beryllium oxide, aluminum nitride, zirconia toughened aluminum. You can see all the metals that we use. So things like moly and titanium go in space. We have some products that are in space right now. And then the alloy filters are just mostly common metals that you find: copper, silver, gold. So these paints and the metal to ceramic assemblies, since they're fired in at very high temperatures, they can withstand very high temperatures, so they can go into space. And they also go into things like rockets and airplanes and jets. Here's some examples. On the left, you see some ceramic to metal brazed assemblies. In the middle, we have just some basic metallization on ceramic. And on the right, you see some ceramic or some sapphire metallization. Sapphire is just alumina ceramic that's single crystal, so it's pulled much like you would do a silicon wafer. In this instance, there's a rod being held by the tweezers there that's got the metallization on it. And below that are 2 sapphire lenses used for things like endoscopy. So they go on the end of an endoscope that gets put into your body so doctors can see inside your body. So we metallize the outside of that, and then we braze it to a piece of stainless or titanium that will then go into your body. So some more pictures. That little part on the penny, that's a US copper penny. That part's got 13, 14 different components that are all brazed together in one step. And then it's actually an X-ray source. So we sell hundreds, thousands of them a year. It's a replacement part for scientific instruments. And that's it. So hope you enjoyed it, and hope it's some inspiration that once you get out of school, there are a lot of different jobs out there that involve space, and you don't have to work for a giant company to participate. I'll hand it back to you, DV.
Thank you, Ed. The point that you made that
you.
Work in space industry, one doesn't have to work in Blue Origin or some other big company. That was a very, very striking point. So as long as somebody wants to work in space industry, there are so many ways to do that, and we will always be happy to help you in that. So ladies and gentlemen, next we have a star speaker. We have Mr. Tim Dyer, who is currently the president of MathC Innovations, who was formerly the president of Elcon Precision. So Tim has a bachelor's and master's in material science and engineering from University of California, Davis, creating and making products at nexus of energy, fabrication technology, and material science is a special feature of the distinguished career of Tim Dyer. Over to you, Tim.
Thank you, DV. Thanks for the introduction. And let's let folks know that Kwang Han Key had to leave. He had a flight to catch. I've worked with him for about 10 years in ceramics. He's a brilliant person with the space industry. And I also want to again thank DV for us coming up with the idea of this series, which is a great series. And it's sort of a bittersweet day for us that this is the last of the series that we'll be doing. And I also appreciate the participation of Ed Tomasek and Nikki's coordination, and then also our guest speakers, which I don't really do well with the long Indian names, so I apologize for being able to do that. So I'm going to present my slides today. Is a very personal topic that I'll be talking about, which is about my journey as a space enthusiast. So this is hopefully people can see this, which is why I'm interested in space and why you should be interested in space and my career. So why I actually became to do what I'm doing out of my humble origins in California. And so this is a journey of a space enthusiast by Tim Dyer. And you'll see on this picture, there's actually from the solar gratings that Elcon made. This is a picture of the sun, which is our second most important celestial body, being that Earth is number one. And without the sun, there wouldn't be much of an Earth. So we have to remember that there's really two important celestial bodies that are very key to our survival, and that's the sun. And the sun is really what my passion is about, is because it's about energy. Let's see if I can do this. A little bit about me, so you understand who I am. I'm a native Californian. I was born in Los Angeles in 1967. I'm the son of a German immigrant with my mother. She was my German immigrant. My father was a U.S., so I'm half U.S. German. Like a lot of people in the United States, it's international, and we all share this planet together. So we're all on this rock. So it's not just, I think as technology has united us, we're really just one people. So I look at everyone as kind of a combination. So that's the way we are. We have to work together. I decided to become a material scientist in 1989. I was a mechanical engineer, and I decided I was more interested in the material science and metallurgy, modern day blacksmith. So I made that change. I love materials engineering. I have a bachelor's and master's degrees in material science engineering from UC Davis, University of California, Davis, UC System, Cal Berkeley, UCLA, great schools to go to, great place to aspire. They like foreign students as well. These are good research institutions that give you the combination of both a research education and also a practical education. There are other good schools like Cal Poly, Polytechnic universities in the United States that combine a little more practical side of things. I'm a very, very practical person, so UC was a very good decision for me. I have my own private company. I was president of Elcon for probably 5 years and worked there for 8. Elcon is a wonderful company, but you kind of grow up as you get older and make changes. And part of that is to start my own company, which is MatSci Innovations. And I've really been working on it for 10 years, and we brought it to life. My hobbies are mountain biking. I'm an avid mountain biker, yoga, traveling, and I like winemaking. I make bad wine. And then in my younger days, I played in a symphonic band, and music is a big part of my life. Here's about my company. It's small. It's just me right now. I do have a contract with a company called Freylock Incorporated for ceramics. So I work with structural ceramics. So used in aerospace and industrial applications to make big ceramic parts. But MatSci Innovations is really my passion. MatSci Innovations is a company that's really focused on bringing new material synthesis and fabrication technologies to help us eliminate the need for fossil fuels. We cannot, as a planet, keep burning natural, gasoline and natural gas. We can't keep doing this. This is not sustainable. And also, if you look at going into space, they don't have this option on the moon or Mars. So we have to evolve as a civilization so that we don't need to use fossil fuels. How do I help? Is I help small companies solve problems. That's what MatSci Innovations does. We can make products, we can synthesize things. That's what we want to do. We want to help you do it with high purity ceramics or powders, high temperature thermal processing like the sun. That's my core competency. A lot of key energy materials require a lot of high temperature processing. Small agile companies that are practical, achieve results quickly with the experience and also attention to details. And then what we want to do is help our energy customers, young energy companies, get the products to market faster so that they can enable market leadership and things can catch on. So this is my way of, I call it paying it forward to keeping the cycle of technology development going so that we can no longer be dependent on fossil fuel. So this is my journey as a space enthusiast. I've always loved space, and it's great that we got Elcon into the space market. That was part of the work that DV helped us with, and it's really been so rewarding. So let's go back to 1970. So I was a little guy. It was like less than 8, 9 years old. And my father would read books to me about the moon landing. And at that time in 1967, that was a big deal. 1969, the moon landing. But folks probably don't remember it. But that's really the beginning of in my opinion, of understanding that you could do something in space. It's amazing to send someone to the moon without any computers. Just imagine that. And so I love the images. And then when I was young, we used a optical telescope, and these are not that expensive. You could find it to look into space. And it's great to work with somebody or to collaborate with someone so they can show you that it's real, that Saturn is real and Jupiter is real. There's a spot on it. Mars is red. This is phenomenal. And then part of the learning process is learning how to find stars. So I'm not sure if all of you know how to find the North Star or Polaris. Is kind of an important thing to do, but it's a great thing to show your children too, or to show others this skill, and then identify the constellations. And then after learning this, I started building rockets, water rockets, and you could buy these. It's like a 2-liter bottle, and you can get a kit with a little nozzle and like a bike pump. You can pump it up, and you can actually make rockets that fly that use water as a propellant in air. These are really simple things to make, but again, it's part of the enthusiasm. My brother and I built and launched solid rockets, STs. We had with different, more sophisticated engines as we got older, and you need parents to help you with that. Or if you're older now, you could probably do it, but it's better to have someone with you because you don't want to get hurt. And then we also gained the passion by watching a TV series in Star Trek, which in our day, there's only like 3 or 4 channels, maybe even some countries 1 channel. But honestly, the information, seeing space on television really is inspirational. And then so you'll see some of the pieces of my youth here. Star maps. I'm hoping that you folks are familiar with star maps, that you could use these, and then you could find them on the internet, and it could really help you get an understanding how real space is. Telescopes are very practical. There's an image of a scope here, which is a very, very inexpensive, or you may know of someone that has it. A lot of times universities will have stargazing nights where you can go and look on internet, and you can actually see the stars, or there could be hobbyists that have this ability. I recommend that you see this to make it real. There's a water rocket here, which are made out of a 2-liter bottle. And then on the right-hand side, there's a solid rocket. You can get a kit. But again, these 2-liter bottle rockets are very inexpensive to make, and it's something that's fun to play with, especially if you have children, you want to share that your passion with them. In the 70s, there was a lot of TV shows that helped us understand space, and Ed Tomasek talked about the blue ion engines, which if you're familiar with a TIE fighter from Star Wars, it's a twin ion engine. It's actually a blue ion engine, so it's a xenon ion engine based spacecraft. When I was young, the big series was Space 1999 because they actually had a moon colony, and they were trying to colonize the moon. And then Star Trek, which really, in my opinion, embodies the boldness of space, of exploration. And then there's the Death Star, which is the enemy in Star Wars. But the whole idea of a large colony or a large planet-sized space colony is I think a phenomenal concept that instead of having the Earth, you could have a large celestial body that you could inhabit, which is again an alternative to say Mars inhabitation would be to have some sort of large space station. In the 1980s, I had to grow up a bit and get educated. So this is when I had my physics, chemistry, and math. And a lot of you may not like it, but the fact is that if you really, really work to understand it, it's really a lot of fun. So I recommend, if you like physics, chemistry, and math, to stick with it. That's really important basics. There's a lot of places that you could see technology. So I know in many countries, there's air museums or air and space museums or public museums. If you can go see the technology, see the space things, read about it, it really makes it personal, and it helps embody the passion. Computers were new when I was young, so I actually bought an Atari 800 XL. It's probably something that maybe find in an antique store now, but that passion, I taught myself BASIC, which is a computer language, which allowed us to do basic commands, which is kind of the beginnings of AI and all these other fancy technology things, is to be able to write computer code to make a machine do something, which is so critical in space. When you can't be out there, you have to have a robot or a machine do something. You need to have to tell it what to do. Programming languages really explain or teach you how to explain something to a machine. I programmed calculators. We used to cheat on exams actually by programming calculators to do advanced calculations at the same time. My brother and I, we built bicycles when we were young, repaired automobiles, and we created inventions like cannons and rocket engines. So these are part of growing up and getting bolder and bolder, but a lot of times it's just collaborating with someone or some friends that can help you work together to make something special. The one big political event, which is not necessarily a great thing, was witnessing the space shuttle, the Challenger mission failure in 1986. This was when I was in high school. I watched this with a bunch of students, and there was a teacher on the craft, which was a devastating failure. But what that inspires you to know is that space is not always safe, and that we have to be cautious. And that actually inspired me to really understand material science, because in the end, the Challenger disaster was a material science failure. And you folks can always read about it. Professor Feynman was one who helped explain the failure issue with Challenger. So again, material science is really important, and it can save lives. And that's what inspired me to do that. Here's some pictures of some history. You have a Boston Space Museum, which my parents took me to when I was young. There's an Atari 800 XL, which is the old computer you can see in the middle. There's a VW motor. So I've always been in cars and motors and engines. It's a very simple motor. I could take that thing apart, no problem. Take me about maybe an hour and a half to completely disassemble that. And then on the right side is a lighter fluid cannon, which is a basic propulsion device. I don't recommend you construct one because they could be hazardous, but at the time, that's pretty much what we had, and it was a great thing to explore. The periodic table, the elements, is actually, there's a few things that I think that are important for students to understand, is that the power and the understanding of the periodic table is critical, and the relationships of the elements and how they behave is very intriguing. I think this is like a universe in itself, understanding the periodic table. The periodic table and the laws of thermodynamics, I think, are the basic guidelines of physics. And chemistry is maybe considered a branch of physics, but the fact is we have to understand that these core sciences really will help us understand how to make modern materials that withstand the conditions in space, that can actually have the properties we need in space, and then understand how we can process them and contain them and make things out of them. In the end, we have to make stuff that handles space, that handles the environment. And it's these elements that Elcon Precision and SpaceX, they actually harness these elements to make these things a reality. So again, high school chemistry, amazing. Things that you may not be excited about now, or you may kind of wonder about, but honestly, it's important to understand the elements, periodic table, and a little bit about the laws of thermodynamics. In the 1990s, I had a modest upbringing. My parents didn't have a lot of money, so I attended Santa Rosa Junior College, which is a local community college, to start my mechanical engineering degree. And at the time, I sold auto parts at a parts store, and I just worked when in school. Probably about 30 hours a week, while trying to pay for my college. I eventually was to save my money, and with some scholarships, I went to University of California, Davis to complete my bachelor's degree in material science and engineering. And I was just fascinated by it. Fascinated so much, I decided to stay for a master's degree in materials engineering at the University of California, Davis. And I was able to do some amazing things. Like when I was there, I built an electron beam evaporator, which is something that takes metals and heats them up hot enough where they vaporize. They boil and they vaporize. I built a furnace that grows germanium crystals, single crystals. And I did this with a few other people, and it was a really great project. And we did it for chemical engineering. And I learned to machine my own components out of aluminum and stainless steel with machine shops. So part of a student, we didn't have any money. So if we needed to make something, you could do some drawings, and then people would teach you how to run machine shop tools. So you run it, you make it yourself. And then there's a great satisfaction of making things and actually making mistakes, which is part of growing up and learning, is that machining is a fantastic way to learn how difficult it is to machine something, to make stuff. And then at UC Davis, I refurbished the ESCA machine, which was a very complicated electron scanning chemical analysis machine, which I was able to throw together as part of my end of my school to make that machine, a very fancy machine. And then I became an employee of Applied Materials. So as I ended up, I actually got a job. So after all that college and all that exploration of space, I actually got a position at a company called Applied Materials as a process engineer. And that's what I think everyone's objective is to get a job. But even though they made tiny things for semiconductor equipment, it still was this passion for space and this enthusiasm for space that kept me going through all this education. Here's some pictures of Santa Rosa Junior College, my quaint little wine country community college. UC Davis is a very formidable school, and it has a material science program. There's over 200 students. It's the largest or second largest material science undergrad program in the state of California. So I recommend, if you're interested in material science, that UC Davis is a great school. And then you can see a picture of an electron beam evaporator. It doesn't look that spectacular, but it's actually really, really hot. Like it's maybe 3,000 centigrade. So then after that, to this time, I worked in the semiconductor industry, making semiconductor fabrication equipment. My specialties have been ceramics, so I'm actually an advanced structural ceramist is my background, making components for medical devices, space flight, lasers. I've made ceramic pumps for desalination. I made components for Perth, Australia, that are used in Israel, Nigeria, North Africa, Egypt in the army. I've made a lot of components for water, the ceramics. Helped enable high energy density lithium batteries using silicon anodes. That's one of my most recent work. And then helped Elcon Precision flourish in the space industry. And then I think the real culmination was the DART mission, was to actually see the DART mission fly, to see the SpaceX craft take off, to watch the collision of DART with the Didymos Prime asteroid was phenomenal. And my daughter, who's been learning about space from me, actually watched that when she was at school with her classmates and said, "Hey, my dad was involved in that spacecraft that collided with the asteroid," really demonstrating that we could actually, as humankind, we could prevent or mitigate a global extinction event, which should takes out the number one planet that we really need to worry about, which is Earth. Number two is the sun. But the whole idea of DART was to demonstrate that humankind working together can actually save the planet if we need to. That's really, really a great culmination of all my work. So what I thought we'd do here is, if people want to contribute, Nikki can take, this is Tim's, I want to be a space enthusiast kit. So what do we want to, what makes us a space enthusiast? So I started off here, and people can welcome to chime in, is that, you need curiosity, imagination, It helps to have some star maps. You got to be willing to learn. It helps to have a knack for math and science. I mean, it really does. You got to be willing to work hard and study. Sometimes you need more than one job. DV knows that. I mean, I know that too. I mean, a lot of people it does. You need to, it's nice to have a person to share your passion with, whether it's a spouse or a friend or maybe a son or significant other, daughter. It's important, I think, that you share your passion. And then also, you know, the skills to find information with limited resources. Nowadays with NASA and ISRO and all the websites and what Kwang Hong has been doing for you know, education, it's a little more available, but still you got to find this information. People don't always give it to you. And DV has a wonderful space education course, which helps you find this information. It's a very efficient way of finding it. But again, you know, you can, you know, you gotta be creative in how you find information. And then, you know, so what else? So I'm not sure if any folks have any, what else, what makes you enthusiastic about space? Don't know if Nikki, if you can.
Yeah, we have, it looks like we have one hand. Someone's raising their hand. D. Sivaraj, I'm gonna allow you to talk.
Maybe you could type in if it's easier.
Yeah.
I don't know if Mr. Balaguranathan, do you have any, what made you interested in space, Mr. B?
Mr. Balaguru, sir.
What inspired you to, what made you interested in space?
Yes, sir. You're asking me, sir? Myself, Balaguran, sir.
Yeah,
Yes,
what made you interested in space? Why are you a space enthusiast?
Actually, in space, to popularize the space science among students, sir, we are doing lot of programs, sir, to get a hands-on experience in the space science, and to explain certain basic principle in physics. We formulated some of the equipments, small equipments. Through this, we can teach the basic principles. Now we are also explaining the principle of the rockets and why we are using this much of rocket for launching for a particular planet, the payload, etc. We are explaining all these things to the students from the standard from 6 to 8, sir.
What do you recommend for students to have? What are good qualities of students that you find?
6 to 7, 8 students, sir. 6, 7, 8. These are all the middle school students, sir. Then after that, we are introducing universe and solar systems and other constellations and celestial events for the 9th and 10th students, sir. For higher secondary students, higher classes, we are introducing satellite, how it is working, what are the different types of satellite. This whole thing is explained to the higher classes. How to fabricate a micro satellite. This is also explained by some of the local agencies, sir. Some of the students are launching satellite of weight nearly 64 kilogram. That is studying the moisture of the atmosphere. The low Earth orbit, sir. In the low Earth orbit, we are launching some of the small rockets, small satellite also. How to fabricate, and we are introducing robotics to the students, sir. And how to introduce artificial intelligence to the students. What are the challenges in near future in artificial intelligence? That is also introduced in the elementary level, sir. They can get a lot of knowledge in their higher level. In engineering degree, they can get some more machine learning and etc. Now we are putting certain foundations for that. These are all we are doing all these things.
Sounds
awesome. These are all outreach programs, sir.
That's great. And thank you. And then I want DV. Why are you interested in space, DV? What inspired you?
We have been traveling to the US so many years, taking business delegations. We worked on machine industry, interestingly, we worked on poultry industry that was 10 years back, and we wanted to work on an industry that will be interesting, that will have work 12 months a year, unless any seasonal industry. And we had some interesting advice from ISRO and from some friends in NASA. So we made a visit to Kennedy Space Museum in Florida about 5 years back, and that was the beginning. That was the beginning, and we couldn't have asked for more. And the journey has been great. But then, Tim, our sincere thanks to you for that wonderful presentation. I would like to particularly, thank, and I'm wondering at the way that you presented a periodic table as a part of your presentation. That was certainly not something that I really loved when I was in the school. But then one gets to know, one matures, or one gets the knowledge or wisdom as one grows, and we wish you a greater glory as your journey continues. Ladies and gentlemen, we have had 189 participants today. That's a record. That's a record of sorts. We had 120 participants in the 4th edition, but then the biggest number is today, where we had 189 participants. We will be presenting certificates to interested participants who contact us and send us an email. We will be very happy to present them certificates. Nikki, do we have a question? Do we have time for questions?
I mean, yeah, we can, if everyone has time. We do have a few in the chat, and let's just briefly go over them. Siva Kumar asked, what are basic qualifications to join the space technology UG course, and the career options after that?
Kumar, we would like to have a little more information on what you are currently doing, and send us an email. We'll be more than happy to help you. We have somebody from a biology background, we have somebody from a material science background, and we have a teacher sitting there. And then, space is big. There is space for everybody. We'll be very happy to help you to identify. We'll be happy to help you identify your core area of interest, and then we can link that to the space industry. We will be happy to do that. Balaguru sir, any inputs? Ed, you have something to say on that?
Well, as you said, I've got a biology degree, but the reason I've been able to kind of work my way into the ceramics business and the metals business is that biology involves a lot of physics and chemistry, and I paid attention in class and learned all that, and that really helped when it came to working with different materials, and especially working with things in space. I mean, it's just stuff is stuff. So if you know that periodic table, it goes a long ways.
Yeah, we have a hand raised by Mr. D. Sivaraj from EEE. D. Sivaraj, Nikki, could you please unmute that gentleman?
Yeah, I'm trying to. Maybe they don't see it, but maybe Rajesh.
Yeah, Radesh. Radesh, your particular question, please.
No.
You type it.
Somebody is asking if they can get the recording of the discussion. Yes, as usual, we would request and depend on the support from Nikki, and we'll be happy to share the recordings.
Yeah. I'll definitely download the recording tomorrow, and then DB can send that out to the registrants.
We take this opportunity to. Is there another question? We see another one. Yeah, sure. Somebody is asking for the recording. So,
yes, someone's asking. I am pursuing a final year in their bachelor's degree in aerospace engineering. And the question is, what qualities do you look for in a student to hire them as an employee in your company? Doesn't say
which company? Is that question to Elcon or Matsy?
I think you need to be willing to put in some effort and work as a team. I think teamwork and collaboration and good communication skills are important. Being smart is not as important as being able to work well with others and to be able to focus and make things, I guess, attention to detail. So that's what I'd recommend, at least at Elcon, is you need to be willing to sometimes put in a long night every once in a while if you need it.
I'm just sending the email ID. Somebody wanted the email ID for further communication. So I would like to take this particular opportunity to thank Mr. Balaguru sir for joining in and for inaugurating this session. Our special thanks goes to Team Elcon, Mr. Tim Dyer, Mr. Ed Tomasek, and Madam Nikki Du. A very, very special thanks to you. We certainly hope to continue this journey, and we certainly look forward to hearing from all the participants. Tim, a final word from you, and then Ed, and then Balaguru sir and Nikki. A last word from you, Tim.
Space it's a global effort. We're all in this together. We all share this planet together. Just remember that. And you can find me on LinkedIn. There are a lot of people on LinkedIn. That's a good way to reach people. And don't be afraid to reach out and ask questions, because we all want you to be in this industry. So don't be shy. Reach out and ask questions, and we like to help.
That's a great message. Don't be shy. Thank you. Thanks for that. Ed, the last word from you, Ed.
Oh, I would say, in addition to that, is always be curious. I mean, we have a lot of problem solvers at Elcon, and it's just keeping an open mind and being curious about how things work and how to make things better. So, and also reach out to us if you have questions.
And Nikki, we know that you are a leader in the making. Can we have a word from you, please?
Sure. I mean, I would like to thank you, DV, and everyone, all the participants. I think for me, even though I haven't really presented, I've learned a lot listening to everyone, especially about space. And space, itself is inspiring, because the technology that, we built upon in space actually affects us down here. So, the cell phones, everything. So it's really inspiring. And I've learned a lot through, listening to everyone present.
Thanks, Nikki. Balaguru sir, a final word from you, please.
It's a very good session, sir. We successfully completed the webinar series, sir.
Yes, sir.
Still, we are ready to join with you in hand to popularize this lecture to some more number of students, sir.
Yes,
we are ready to
yes.
reach a more number of colleges in future.
Yeah.
Definitely we'll do, sir. Thank you for the opportunity, sir.
Thank you. Thank you, Balaguru sir. Ladies and gentlemen, with those words, this excellent series, international webinar series on future of space technology and exploration comes to a grand close. Our sincere thanks again to all the participants, Mr. Tim Dyer, Mr. Ed Tomasek, Madam Nikki Du, and Mr. Balaguru sir, and to all the participants from various colleges across different geographies. Thank you, everybody. Thank you so much. With this, this session comes to a close. Thank you. Thank you. Goodbye.
Bye-bye.
Thank you.
Thank you.
Bye-bye.
Thanks to participants.
Thank you. Thank you. Thank you to all the participants. Thank you so much. Thank you, sir. Thank you. Thank you. Good night. Good night to all the participants in the US.